So now for the performance test of mini ice plant, dito yung mga type ng ice plant, tsaka yung mga needed parameters sa performance. So start tayo sa ice maker. Ice maker yung mga mini ice plant. An ice maker, ice generator, ice machine may refer to either a customer device for making ice found inside a home freezer. Sa freezer nyo, makakagawa kayo ng yelo. A stand-alone appliance for making ice, special equipment like industrial machine for making ice on a large scale. The term ice machine usually refers to the stand-alone appliance for making ice. The ice generator is the part of the ice machine that actually produces the ice. This would include the evaporator and any associated drives, control, subframe that are directly involved with making and ejecting the ice into storage. When most people refer to an ice generator, they mean this making subsystem alone, minus refrigeration. Diba? So an ice machine, however, particularly if described as package, would typically be a complete machine including refrigeration and controls, requiring only connection to utility. Sasaksak mo na lang, power on. The term ice maker is more ambiguous, with some manufacturers describing their packaged ice machine as an ice maker, while others describe their generator in this way. So, principle of ice making. All refrigeration equipments are made of 4K components: the evaporator, the condenser, the compressor, and the throttle valve. In refrigeration system, ice machine all work the same way. The function of compressor is to compress low pressure refrigerant vapor to high vapor pressure and deliver it to the condenser. Here, the high pressure vapor is condensed into high pressure liquid and drained out through the throttle valve to become low pressure liquid. At this point, the liquid is conducted to the evaporator, where heat exchanging occurs and ice is created. This is one complete refrigeration cycle. Take note, refrigeration cycle is yung pinaka-effective para maano mo yung cooling, effective sa cooling. Making ice, air conditioning, yan ang pinaka-effective. Meron tayong mga bago ngayon, that is hindi bago. Mga luma na yun na jury, mga compressed air ginagamit, tulad nun, may iba-ibang refrigeration cycle, walang evaporator, condenser, compressor, at least mga hindi yun bago, mga luma na yun. At least yun yung mga low performing, baba efficiency, high cost. So ngayon, pinopromote ulit nila. Akala mo, bago. So kung check nyo yung theory, matagal na mga theory yun. Industrial ice maker. So commercial ice cube makers, improves the quality of ice by using moving water. The water is run down a surface that is constantly at 0 C because only water without impurities will freeze at this temperature on a surface. Water with impurities requires lower temperature to freeze and will continue to wash down the surface through the drain of a commercial ice maker. Air and undissolved solid will be washed away to such an extent that in horizontal evaporator machines, the water has 98% of the solids removed, resulting in very hard, virtually pure, clear ice. In vertical evaporators, the ice is softer, more is so if there are actual individual cube cells. Commercial ice machines can make different sizes of ice like flakes or flakers, crust, cube, octagon, and tube. Yung mga itsura ng ice. When the sheet of ice on the cold surface reaches the desired thickness, this sheet the sheet is slid down onto a grid of wires, where the sheet's weight causes it to be cut into the desired shape, after which it falls into storage bin. Flake ice. Na natin yung flake ice from industrial machine. So ito yung mga flake ice. Ayan. Hindi yan. Itong wala yan sa PowerPoint yan. Template. So flake ice is produced by applying water to the inside or outside of a refrigerated drum or to the outside of the refrigerated dish. The drum is either vertical or horizontal and may be either stationary or fixed. The disc is vertical and rotates about the horizontal axis. Ice, yan. Yung mga nag-iilo sa surface, no, yun yung ice flakes, flake ice. Ice removal devices fracture the thin layer of ice produced on the freezing surface of the ice maker, breaking it free from the freezing surface and allowing it to fall into the ice bin, which is generally located below the ice maker. So, nag-gets niya. The thickness of the ice produced by flake ice machine can be varied by adjusting the speed of the rotating part of the machine, varying evaporator temperature, or regulating the water flow on the freezing surface. Flake ice is produced continuously, unlike tubular and flake ice, which are produced in an intermittent cycle or harvest operation. Yung bang by batch. Tubular, paputol ka. Yan. The resulting thickness ranges from 1 to 4.5 mm. A continuous operation without a harvest cycle requires less refrigeration capacity to produce a kilogram of ice than any other type of ice manufactured with similar makeup water and evaporating temperature. So the exact amount of refrigeration required varies by the type and design of flake ice machine. Typical flake ice machine as in figures 1 and 2. So dito siya. Accumulator, pasok doon. So dito yung drum. Rotor, umiikot siya dyan sa gilid yung ice making surface. So, dyan, kumakapit dyan. Magtitigas tapos bababa na doon. So yan, mga check nyo na lang. Yung drawing. So dito yung actual. So may makikita ka niyan, di ba? Sa mga planta ng ice. So andyan yung drum. That is flake ice machine. So all water used by flake ice machine is converted into ice. Therefore, this is no waste or spillage. Flake ice maker are usually operated at a lower evaporating temperature than tube or flake ice machine, and the ice is colder when it is removed from the ice making surface. Now, the surface of flake ice is not weighted by thawing during removal from the freezing surface, as is common with other type of ice. Since it is produced at colder temperature, flake ice is most adaptable to automated storage, particularly when low temperature ice is desired. The rapid freezing of water on the freezing surface entrains air in the flake ice, giving it an opaque appearance. For this reason, flake ice is not commonly used for application where clear ice is important. So, where rapid cooling is important, such as in chemical processing of concrete cooling, flake ice is ideal because the flakes presents the maximum amount of cooling surface for a given amount of ice that ginagamit. So when used as ingredient, ice in sausage making or other food grinding and mixing, a flake ice provides rapid cooling while minimizing mechanical damage to other ingredients and wear on mixing cutting blade. Some flake ice machines can produce salty ice from seawater. These are particularly useful in shipboard application. Other flake ice machines require adding trace amount of salt to make the makeup water to enhance the release of ice from the refrigerated surface. In rare cases, the presence of salt in the finished surface and the finished product may be objectionable. Diba? Next, ang mga ice is yung tubular ice. Tubular ice is produced by freezing a falling film of water either on the outside of the tube with evaporating refrigerant on the inside, or on the inside of a tube surrounded by evaporating refrigerant on the outside. So ito sa tube to ang tube, yung isa sa drum. So ang labas doon is flake ice. Outside tube, when ice is produced on the outside of a tube, the freezing cycle is normally 8 to 15 minutes when the final ice thickness from 5 to over 13 mm. Tubular ice siya. Following the curvature of the tube. The refrigerant temperature inside the tube continually drops from an initial suction temperature of negative 4C to a terminal suction temperature in the range of negative 12 to 26C to negative 26C. So at the end of freezing cycle, the circulating water is shut off and hot discharge gas is introduced to harvest the ice. Yan. To maintain proper harvest temperature, typical discharge gas pressure is 1.1 megapascal. Yan. So, yan naman ipapalit pa doon sa refrigerant. So, yan ang harvesting. So, kakalas yung ice mo sa tube. So, this drives the liquid refrigerant in the tube up into an accumulator and melts the inside of the tube of ice, which slides down through a sizer and mechanical breaker, and finally down into storage. Breaker yung cutting. The defrost cycle is normally about 30 seconds. The unit returns to this freezing cycle by returning the liquid refrigerant to the tube from accumulator, then stack yung refrigerant. So this type of ice maker operates with refrigerant R717. Ano yan? Ammonia. R404A, R507, and R22. R12 may be found in some older unit. Pero ngayon, bawal na ang R22. R22, ganun din. Higher capacity units of 9 megagrams per 24 hours and larger usually use R717. So the capacity of the unit increases as the terminal suction pressure decreases. A typical unit with 21C makeup water and R717 active refrigerant produces 17.5 megagram of ice per 24 hours with a terminal suction pressure of 265 kilopascal and requires 126 kilowatt of refrigeration. So ito yung performance niya. This equates to 7.2 kilowatt of refrigeration per megagram of ice. So the same unit produces 37.7 megagram of ice per 24 hours with a suction temperature of 145 kilopascal and requires 280 kilowatt of refrigeration. This equates to 10.5 kilowatt of refrigeration per kilogram of ice. Figure shows a typical physical arrangement for an ice maker that makes ice on the outside of the tube. So ito, meron tayo nito sa atin. Yan. Pero sa Legazpi. Mga ice plant dito na ganyan ang itsura. Okay? That is tubular ang labas niya. So inside, outside tube. For inside tube, so walang figure. Sige lang. Next year na lang ang figure. So inside tube, when ice is produced inside a tube, it can be harvested as a cylinder or crushed ice. The freezing cycle ranges from 13 to 26 minutes. The tube usually has 20 to 50 mm in diameter, producing a cylinder that can be cut to desired length. The refrigerant temperature outside the tube is continually dropping with an initial temperature of negative 4C and a terminal suction temperature ranging from negative 7 to negative 20C. At the end of the freezing cycle, the circulating water is shut off and the ice is harvested by introducing hot discharge gas into the refrigerant in the freezing section. To maintain gas temperature, typical discharge pressure is 1.2 megapascal. This releases the ice from the tube. The ice descends to a motor-driven cutter blade that can be adjusted to cut the ice cylinder to the length desired up to 40 mm. At the end of the cycle, the discharge gas valve is closed and water circulation resumes. These units can use refrigerants R717 and R22. R12 may be found in older units. Again, the capacity increases as the terminal suction pressure decreases. A typical unit with 21C makeup water and R717 as the refrigerant produces 39 megagram of ice per 24 hours with a terminal suction pressure of 7.75 kilopascal and requires 262 kilowatt of refrigeration. This equates to 580 kilojoule per kilogram of ice. So the same unit produces 60 megagrams of ice per 24 hours with a terminal suction pressure of 210 kilopascal and requires 475 refrigeration. This equates to 684 kilojoule per kilogram of ice. Next, tubular pala. Tubular ice maker are advantageous because they produce ice at higher suction pressure than other types of ice makers. They can make relatively thick and clear ice with curvatures that help prevent bridging and storage. Tubular ice makers have a greater height requirement for installation than do plate or thick ice maker but a smaller footprint. Provision must be, yan tataas, di ba? Provision must be made in the refrigeration system high side to accommodate the volume of refrigerant required for the proper amount of harvest discharge gas. Ice temperatures are generally higher than the temperature of the brick ice. Supply water. Supply water temperature has a great effect on the capacity of either type of tubular ice maker. If the supply water temperature is reduced from 21 to 4C, the ice production of the unit increases approximately 10%. Larger system, economics of pre-cooling the water in a separate water cooling system with higher suction pressure should be considered. Okay. Next is the plate ice. So yan. Mapit na. Konti lang naman to description lang to sa kanyang mga common sizes, common parameters. So plate ice makers are commonly defined as those that build ice on a flat vertical surface, which water is applied above freezing plate during the pre-cycle. That's a figure. Freezing cycle and harvesting cycle. Liquid refrigerant at temperature between -21 and -C is contained in the circuiting inside the plate. The length of the freezing cycle governs the thickness of ice produced. Ice thicknesses in the range of 6 to 20 mm are quite common, with the pre-cycle varying from 12 to 45 minutes. So from figure 11 shows a diagram of plate ice maker using water for harvest. All plate ice maker use a sump and recirculating pump concept, whereby an excess of water is applied to the freezing surface. Water not converted to ice on the plate is collected on the sump and recirculated as called water for ice making. Yan. Yung plate ice. Plate yan, flat yan, flat na flat. So yung sa dam, hindi yung flat kasi nakapalot ka sa crack. Ano yun, sa dam. Diba? Ito yung pinakamalaki, kumbaga flat na siya, flat. Sunod is yung sa plate. Then, palit na palit yung pagkabilog mo is magiging cube. Oh, is ano, tubular. Tapos yung maliit naman na size, square, cubical size, cube ice naman. Okay, so ito na, sa cube ice tayo. Cube ice machines are classified as small ice machine in contrast to tube ice machine, like ice machine or other ice machine. Common capacities range from 30 kg or 66 pounds to 1,755 kg or 3,869 pounds. Since the emergence of cube ice machine in the 1970s, they have evolved into a diverse family of ice machine. Cube ice machines are commonly seen as vertical modular model. The upper part is an evaporator and the lower part is an ice beam. The refrigerant circulates inside pipes of a self-contained evaporator, where it conducts the heat exchange with water and presses the water into the ice tube. When the water is thoroughly frozen into the ice, it automatically releases and falls into the ice beam. The ice beam can also be equipped with compressor. Why? Generally, cube ice machine with over 320 kg or 710 pounds capacity have built-in compressors in the ice bin for storage prior to sales for when demand are large. Cube ice is created in cubic shape with its edge usually between 15 and 35 mm or 916 to 128 inch. The surface area of every ton of cube ice is approximately 1,383 square meter or 14,890 square feet. So yeah. So another parts of ice machine is the compressor. Most compressors are either positive displacement compressor or radial compressors. Positive displacement compressors are currently the most efficient type of compressor and have the largest refrigerating effect per unit single unit, 400 to 2,500 tons. They have a large range of possible volt power supply and can be 380 to 1,000 volts or even higher. The principle behind positive displacement compressor utilizes a turbine to compress refrigerant into high pressure vapor. Positive displacement compressor are of four main types: mayroong screw compressor, rolling piston compressor, reciprocating compressor, and rotary compressor. For the screw compressors can yield the largest refrigerating effect among positive displacement compressor, with their refrigerating capacity normally ranging from 50 to 400 tons. The screw compressor can also be divided into single screw and dual screw. Dual screw type is more often seen in use because it is very efficient. Okay, so for the rolling piston compressor and reciprocator compressors have similar refrigerating effects, and maximum refrigerating effects can reach 600 kilowatt. Reciprocating compressors are the most common type of compressor because the technology is mature and reliable. The refrigerating effect ranges from 2.2 kilowatt to 200 kilowatt. They compress gas by utilizing piston force via crankshaft. Now, for the rotary compressors, mainly used in air conditioning equipment, have a very low refrigerating effect, normally not exceeding 5 kilowatt. They work by compressing gas using piston force by the rotor. So, yeah. Next is the condenser. So, another part ng refrigeration system. All condenser can be classified as one of the three types: air cooling, water cooling, and evaporative cooling. An air cooling condenser uses air as the heat conducting media by blowing air to the surface of condenser, which carries heat away from the high pressure, high temperature refrigerant vapor. Next, a water cooling condenser uses water as the heat conducting media to cooling refrigerant vapor to liquid. An evaporative condenser cools the refrigerant vapor by using heat exchange between the evaporator pipe and the evaporated water, which is sprayed on the surface of the pipe. This type of condenser is capable of working in warm environment. They are also very efficient and reliable. So this is the end of this mini ice plant topic.